There is a stone in Egypt that nobody has ever finished. It is longer than a 10-story building is tall, wider than a 2-lane highway, and heavier than a fully loaded jumbo jet. It has been lying on its side in a granite quarry for more than 3,000 years, cracked, abandoned, half carved out of the bedrock that gave birth to it. If it had ever stood upright, it would have been the largest single piece of stone ever shaped by human hands in the ancient world. Instead, it is a monument to failure. Or at least, that is what we have always been told. But when you look closely at the walls of the quarry surrounding that broken giant, the story starts to fall apart. Because the marks left behind in that granite do not look like the marks of people giving up. They look like the marks of people who knew exactly what they were doing, using methods we are only now beginning to understand. This is the unfinished obelisk of Aswan, and for over a century it has been treated as little more than a curiosity. Tourists walk past it, snap a photo, and move on, assuming the story is simple. Ancient workers bit off more than they could chew, the stone cracked, and they walked away. But the quarry itself tells a far more interesting story, one that has only recently started to be pieced together properly by archaeologists, geologists, and engineers working together instead of in isolation. And what they are finding is forcing a real rethink of just how advanced ancient Egyptian stoneworking actually was. Let's start with the stone itself, because the material matters enormously here. The rose granite of Aswan is some of the hardest, densest rock available anywhere in ancient Egypt. It sits at roughly 6 to 7 on the Mohs hardness scale, which puts it well above the metals the Egyptians are known to have worked with. Copper, their primary metal for tools during the Old Kingdom, sits at around 3. Bronze, once it came into wider use, is only marginally harder. In simple terms, you cannot cut granite with a copper chisel the way you'd cut a block of limestone. The chisel would blunt, deform, and fail long before the stone gave way. So how, exactly, did a civilization without iron or steel manage to quarry, shape, hollow out, and polish some of the hardest stone on the planet, over and over again, for thousands of years? For a long time, the textbook answer was simple, almost dismissively so: they pounded it. Ancient workers used hand-sized to 20-pound balls of dolerite, a volcanic stone nearly as hard as granite itself, and literally hammered away at the rock, chip by chip, until a groove or trench formed. Thousands of these dolerite pounders have actually been found scattered throughout the Aswan quarries, worn smooth, some cracked from use, discarded once they became too rounded to work efficiently. This part of the story is not speculation. It's solid archaeology. We have the tools. We have the quarry. We have experimental studies where modern researchers picked up dolerite balls themselves and pounded away at granite to see what would happen. And here's the thing, it works. Egyptologists like Denise Stocks spent years doing exactly this kind of experimental archaeology, replicating ancient techniques by hand to see if they could actually produce the results we see in the historical record. Pounding granite with dolerite absolutely can carve a trench. It's slow, brutally exhausting work, but it is physically capable of shaping even the hardest stone, given enough time and enough workers. That much has been demonstrated, not just theorized. But pounding alone doesn't explain everything in that quarry, and this is where the real mystery starts. Because dolerite pounding produces a very particular kind of surface, rough, irregular, full of tiny variations in depth and shape, because no two swings of a heavy stone by a tired human arm are ever exactly identical. That's simply how percussion work behaves. And yet, in sections of the Aswan quarry, especially around drill holes and certain cut surfaces, we see something that doesn't quite fit that picture: long, smooth, spiral-shaped grooves. Curved striations that circle steadily, almost like a corkscrew, cut into granite with a level of consistency that hand-pounding struggles to reproduce. This is where the story gets genuinely fascinating, because the explanation isn't some lost super technology. It's something almost more remarkable. The Egyptians appear to have used copper tube drills combined with an abrasive, most likely quartz sand, to bore into granite. Instead of copper cutting the stone directly, which it can't do, the copper tube acted as a carrier for the sand. As the tube was rotated, likely by a bow drill mechanism, or simply turned by hand with weighted assistance, hard quartz grains trapped between the copper and the granite did the actual cutting, grinding away material in a slow, spiraling path. This produces exactly the kind of curved, striated marks we see on many granite artifacts across Egypt, including sarcophagi, obelisk holes, and vessel interiors. Egyptologists have found stone cores, literally the cylindrical plugs left behind by tube drilling, bearing spiral grooves that match this exact process. Some of these cores are on display in museums today. So when people look at the smooth, curved cutting marks in the Aswan quarry and assume they must be evidence of some rotary power tool from a lost advanced civilization, the truth is both less exotic and, in its own way, more impressive. Ordinary people, using copper and sand and patient rotational motion, were capable of cutting some of the hardest stone on Earth with a level of precision that still surprises us today. No power source beyond human effort was necessary, just a clever application of the right abrasive against the right metal, repeated for as long as it took. Now, what about the deep, narrow shafts found throughout the quarry, some descending 30 to 50 feet into solid granite, barely 3 or 4 feet wide? These are often framed as impossible to explain, but the leading interpretation among quarry archaeologists is fairly grounded. They were test shafts, sunk to check the internal quality of the stone before committing months of labor to extracting a massive block. Granite can have hidden flaws, mineral veins, or fracture lines invisible from the surface, and a bad block discovered halfway through extraction would waste enormous time and resources. Cutting a narrow test shaft first, however punishing the working conditions, was a far more efficient use of labor than gambling on a flawed block. Were those conditions brutal? Almost certainly. Cramped, dark, dusty, and physically demanding. But brutal and inefficient is not the same as impossible, and there's no requirement that ancient labor be comfortable to be effective. Egyptian construction projects across the board relied on enormous, coordinated, and often grueling manual labor forces. As for the idea that granite was somehow melted, fused, or cut using materials like diamond dust, this is where we have to be honest about the line between genuine archaeological findings and speculation dressed up as discovery. There is no verified, peer-reviewed study showing melted mineral grains or industrial abrasives like diamond or corundum in the Aswan quarry marks. Claims like this circulate widely in documentary-style content online, often presented with invented statistics, less than 5% variation, less than 3% spacing deviation, numbers that sound scientific, but don't trace back to any published research. It's worth being skeptical of any claim, however dramatic, that isn't tied to an actual named study you can go look up. The real story doesn't need embellishment to be compelling. The documented techniques alone, dolerite pounding, copper tube drilling with sand abrasive, and dolerite-assisted trenching around massive blocks, already represent an extraordinary level of technical sophistication for a Bronze Age civilization. So then, what actually happened to the unfinished obelisk itself? This is where the physical evidence is unusually clear, because we can see the failure with our own eyes. Workers had cut deep trenches around all 3 sides of the obelisk, separating it from the surrounding bedrock, preparing to free its underside next, likely by tunneling beneath it and levering it free, a technique attested elsewhere in Egyptian quarrying. But partway through this final stage, a crack appeared, running diagonally through the stone. Not a small surface flaw, a structural fracture that would have compromised the entire piece. And so, after what may have been months or years of labor by hundreds of workers, the project was simply abandoned. No monument, no burial, no destination. Just a half-freed giant left exactly where it failed, a snapshot frozen in granite of the exact moment ambition met the limits of the material. What makes the obelisk so valuable to archaeologists isn't the failure itself, it's that the failure preserved the entire extraction process in a way that a completed monument never could. Every tool mark, every trench, every worker's footpath is still there, undisturbed, because nobody ever came back to finish the job or clean it up. It is, in a very real sense, an accidental time capsule of Egyptian quarrying technique, caught mid-sentence. There's also a chronological wrinkle worth mentioning honestly, because it does complicate the picture, even if it doesn't require inventing a lost civilization to explain it. Prehistoric rock art, red ochre paintings of animals and human figures, styles associated with cultures that predate the pharaohs, has been documented in the wider Nile Valley region, including areas near some quarry sites. Where such paintings genuinely overlay older stonework, it does suggest at least some quarrying or stone shaping activity in the region predates the dynastic period as conventionally understood. But this is a far more modest claim than a lost, technologically superior prehistoric civilization built the precision cuts, and the Egyptians simply inherited them. The honest, evidence-based position is that Nile Valley peoples were interacting with and modifying stone surfaces earlier than the classic start date of dynastic Egypt, not that an unknown supercivilization possessed rotary power tools and industrial abrasives that vanished without a trace. Extraordinary claims like that require extraordinary evidence, and so far, that evidence hasn't materialized in any credible, checkable source. None of this makes the real story any less remarkable, though. Think about what we can actually confirm: a civilization working primarily in copper, without iron, without any powered machinery, figured out that spinning a soft metal tube against hard granite does almost nothing. But spinning that same tube with an abrasive sand trapped underneath it slowly grinds a perfect cylindrical hole. They figured out that dolerite, a stone nearly as hard as granite, could be repeatedly dropped and dragged to wear away trenches with astonishing consistency across projects that took months. They figured out how to test stone quality before committing labor to a block. They figured out how to align cuts with the internal grain and weaknesses of the rock, maximizing yield and minimizing waste, presumably through generations of accumulated, hard-won trial-and-error experience passed down through specialized quarry workers. That is not evidence of a mysterious outside influence. That is evidence of a sophisticated, specialized, professional class of stoneworkers who understood their material intimately, engineers, essentially, without the title. And that, honestly, is the real answer that changes everything, not that some unknown advanced civilization did this for them, but that we have consistently underestimated what focused human ingenuity, patient experimentation, and generational knowledge transfer can accomplish without modern tools. The Egyptians weren't cutting granite with mystery technology. They were doing something arguably more impressive, solving one of the hardest materials engineering problems in the ancient world using copper, sand, stone, water, rope, and an enormous amount of accumulated expertise, refined over centuries until it became a functioning industrial process, one capable of supplying granite for temples and monuments across the length of Egypt. The unfinished obelisk still lies exactly where it was abandoned, cracked and silent in the quarry at Aswan. It never became the towering monument its builders intended. But in its failure, it left behind something arguably more valuable than a finished obelisk ever could have: a complete, unedited record of exactly how ancient Egyptians solved one of the hardest engineering problems of their age. The mystery was never really about lost technology from a vanished civilization. The real mystery, and the real achievement, was how much could be accomplished with so little, by people we still, after thousands of years, continue to underestimate.